Welcome to another LeetCode video. In this video, we'll be solving one of my favorite problems on LeetCode, top k frequent elements. Let's get started. So top k frequent elements. The problem asks that we need to sort this, or not sort this. We get an input array and then we need to find the elements that have the highest frequencies. So in this array, we see that there's 3 ones, 2 twos, and 1 3. So we need to return the top 2 most frequent elements, which is 1 and 2. And in this one, there's just number 1, and we're asked for a 1 number, so we can just return 1. So when you first think of this problem, you probably thought of sorting first. So if we sort an array, this array is not sorted, or it's not given sorted. So if we sort the array and then we do a linear scan for the most frequent elements, we should be able to get the answer. But the time complexity for that obviously would be n log n plus n, which is just n log n. But if you see in the follow-up, we have to make it better than n log n because they're already assuming that we thought of sorting. So yeah, we can't really do sorting for this problem. But it's good to talk through if you're like in an interview or something, because that's also a possible solution. But they usually ask a follow-up, or you have to make it better than n log n. So let's make it better than n log n. So the approach for this problem is that we need 2 hash maps. Our first hash map is just going to be the basic one where we find the frequencies of each element. So let's just make our first hash map right here. So we have our keys and value. So our keys are going to be the numbers. So 1, 2, and 3. And the values are going to be our frequencies. So 1 occurs 3 times, 2 occurs 2 times, and 3 occurs 1 time. So those are our frequencies. And now we need to split these up into buckets of the frequencies. Or let me explain this way. So we have our second hash map right here, and we have our value is going to be an array of the numbers that occur on each frequency. In this example, there's only 1 number for each frequency, but just say that we had like more numbers, like 4 occurs 2 times. And then we'll have an extra one that looks like this. So there'll be 2 with the value of 2. And we can split it up like this. We can split it up into buckets of each frequency. So the frequencies that occur in this are 3, 2, and 1. So this frequency occurs only once at number 1. So our array will just be number 1. 2 only has number 2. And 3 only has number, wait, I messed it up. 2, 1, 3, 1, 2, 2, 1, 3. So we're basically just flipping this, we're flipping the arrays around. So, or we're flipping the keys and values around. So now we have the second hash map constructed with the keys and values, where the values are the numbers according to the frequencies. So now we can just do a reverse scan of the values that we need. So if you see right here, we have this constraint right here, the number of unique elements in the array. So we're guaranteed to have k number of elements in the array. So we can just reverse scan from the given k value, and then we can append the value to an output array. So let's say that we have, or for this first problem, we have k equals 2. So we start searching with 2, and we see that we have, never mind. I explained that pretty bad. Let me restart. So we have 2 of the top most frequent elements, and we need to reverse scan from the highest number in the, we need to reverse scan from the highest frequency in this list. So we start from 3, and then we have the value of 1. So the output array, we start searching from 3, so we append 1 to the list, and then we go to 2 because that's the next number in line. So then we have to append 2 to the list. So now we can check that the length of this output array is going to be the same as our k value. And once they're the same as the k value, then we can just return the output array, because then we know that our format is correct, because k basically represents the length of our output array. So Yeah, the time complexity for this one would be O of, let's think. So we go through to find the frequencies once, so that's n. And then we flip around the first hash map into these things. So in the worst case, that'll also be n. And then we also go through this. So it would be n plus k. So if we just simplified this, it would be O to the n plus k time. And then our space complexity would be, we're only constructing, or we're constructing two hash maps. So our first hash map in the worst case would be size of n, where n is the size of the input array. Our second hash map would also be O to the n in the worst case. So yeah, our space complexity would also be O to the n. So yeah, that's the conceptual through this problem. Let's work this out in LeetCode. So let's figure this out. We have our first hash map where we need to find the frequencies. So I'll just call this freaks. And I'll make this default to an integer. So to find the frequencies of each one, we just go through the numbers inside of the input array, and then we just add 1 to each of the keys. So the key is going to be our number, and we just add 1 to those to find the frequencies. So the next one, I'll just call it buckets. We're creating buckets of the numbers, and we'll call this, or we'll do default dictive list, because we need the list to be the value in this one so we can append the values to them. And for this one, we just need to go through the numbers in, let's see how you can do it two different ways. I'll just go through I'll go through the keys, and then I'll insert the values like that. So let's do, so what would be the key in down? It would be, I'll just call it num dot keys. And for this one to work, we need to insert wait, let me think about this again. So we need to insert the frequencies. So that would be the key of the other one. And we'll just append the number to that bucket. And now we should have our hash map that looks like the frequencies with the keys and what the numbers that correlate with those frequencies as the values. So now how would we search from reverse? So we would go from the length. Oh, that's what I was missing last time. So when we need to do a reverse search on this hash map, we can go from the length of the given input array, because if you think about frequencies, the highest the frequency that a number could have is the length of the input array. Because let's say these were all ones, so we would have 6 ones, and it can never exceed that because our input array size is 6. So we know that we have to search from the input array size. So let me just there we go. So that's our that's what we're gonna reverse search from. So let's make a little for loop that searches reverse. So and we can go to 1 because it's in the range of 1 to the unique number of elements in the array. And this one was inclusive, so we don't need to make that anything else. And then just do a little -1 to flip around that. So this will go from the length of the input array, and then it'll count down from 1 until it reaches 1. So now we also need to create an output array. So that's our output array. And for every index, we need to search this frequencies. So in our buckets, we need to if the length of the bucket at the ith index is not equal to 0, and then we just go through the buckets actually we have, let's split this up real quick. So we have bucket. So that'll equal to the list given to the frequency. And we'll just call this bucket too. So now we'll just go for all the numbers inside the bucket. We append it to the output array. And then yeah, that should work. So our next check should be if we are the length of our output array is equal to the k value, then we'll just return the output array, because then we know that we have the k most frequent elements. So we'll do the length of the output is equal to our k value, then we'll return the output. And let's see if this works. This should work. And why is that? Oh, oops. Wow, I'm spelling everything wrong now. And I got the wrong answer for that. What did I do wrong? So we have k equals 1, and then our output array is nothing. Let's see. Did I do that wrong? Oh, okay, there it was. Okay, then this one is not inclusive. I thought this one would include number 1, but apparently it didn't. So yeah, that's how we do k most frequent elements. Hope you found this video helpful. Thank you.